Have you ever wondered what happens when memory leaks in Java? Well, typically we might think about a Java heap memory leak, where objects are stored and never garbage collected. But there can also be situations where the native memory in the non-heap memory begins to leak. Our focus today will be on understanding native memory leaks and how to detect and troubleshoot them. Java memory consists of several pools that an application can access and allocate from. We're all familiar with the idea that Java objects are allocated into the Java heap. In addition to the Java heap, there are other JVM-managed memory spaces such as metaspace, stack space, native area, and reserved. Here's where it gets interesting. The JVM and the native code of applications can make allocations out of native memory. These native allocations can be done by JNI allocations made by the G8 compiler, or the creation of new threads by the JVM. As native allocations can be made from several different places out of your code, it's not exactly a walk in the park to debug them. So, what are the symptoms of a native memory leak? Under normal circumstances, the sum of the heap and non-heap memory consumed by JVM should be comparable to the total memory consumption of the Java application. But if the total memory consumption is constantly increasing with no increase in heap and non-heap memory, then you likely have a native memory leak. There are several reasons for native memory leaks. It could be due to any application calls to malloc to acquire memory. If it discards the reference without calling free, the OS thinks the process still has memory, but it has already lost the reference to it. It could also be due to JNI allocations, GIT compiler allocations, or the creation of new threads. Another reason could be a class loader leak, which increases the metaspace and results in an increase of the total memory consumption. To detect and troubleshoot these leaks, several tools are required. These include the JCMD utility, native memory tracking, hprof for heap profiling, Java Visual VM for memory consumption, running threads, classes monitoring, the JDB utility for connectors and listeners, the JMap utility for heap dump, and the JStack utility. In summary, Java's memory model is complex, with several different pools of memory that an application can access and allocate from. Native memory leaks can be difficult to detect and troubleshoot, but with the right tools and understanding of the symptoms and causes, they can be managed effectively.